we just did just a little precursor. This is Buddy coming in.
Oh, good.
We did a precursor yesterday looking at, they're kind of classic, but they're always good. But it's Shiprock and of course it's Robert's here, Upheaval Dome, so.
And the Eye of Africa.
And the Eye of Africa, right? Yeah.
I just wanted to discuss that, and I mentioned it to Robert this morning on a message.
Right. I'm looking forward to getting into this. This is going to be a good episode here.
I was rubbing our hands together, let's do this.
Yeah.
Yeah.
Welcome to the September 2nd edition of The Electric View. I'm Neil Thompson. Today we have Heather, Buddy, Dave, Richard, Jim, and Robert with our special guest, Andy Hall. We'll be taking our time to discuss the formation of multiple landscapes around the planet, our trips out to see these geological features, and why some volcanoes may not be volcanoes at all. Don't forget to like and subscribe.
Yeah, thanks for joining us today. So we're excited to have you on again.
I'm happy to be on. Sorry I haven't been around for quite a while, but
all things considered.
Yeah. Big life change in my life, so I just kind of distracted me from EU stuff for quite a while.
Right. But welcome back, though.
Thank you.
It's definitely good to have you. It doesn't really, so what have you been doing? I haven't talked to you in 48 weeks.
Probably. It's been, well, as you know, my brother passed away, and that was kind of the big life-changing thing, because when he passed away, he managed sort of the family business here, which is, the properties where you visited, Neil.
Right.
And so that fell to me, and I moved in and took over managing the properties. And right at that time, there was just a whole lot of things going on, a bunch of things that I had to work on. And so I just didn't have much time or anything for anything else other than trying to get my life back in order, because it was pretty well disrupted.
That's, I'm sorry to hear that, of course. That was surprising. I actually found some pictures of Dawn there when we went out driving, and when we went up back around the mountains there behind Tucson, to see the backsides, and how we were all raring to go, and that was the third day after we got back or something, and everything was finally calming down, and I just passed right out there in the car, in the Honda. I was just but and of course I love that just the little he was very kind. I've always remembered that, keeping me in the air conditioned box so I didn't overcook.
Yeah, you slept out in the motorhome. That's the spare bedroom. Yeah,
that was great. I still remember I still enjoyed the mountain climbing there and all the things that we found. Just when you were telling me about the mines up the side, and you can really see, being where you're from, you can see the effects of the land, and obviously it played great. We just saw your new upload there from the Thunderbolts, the video, EU 2017
conference. Yeah. Well, those are the Catalinas you've got up there on the screen. So that's where we were, Mount Lemmon. Yeah, you can really see the geology there, and the form of the mountain it's different from a lot of mountains. The Catalinas are a little bit different, and so you can see a lot of things there that kind of make it, to me, more obvious that wind formed the thing.
And it's now coming to see what it looked like. We've seen there's a fellow that we had on not too long ago, Jacob Gable, who was doing. He has a bottle which he does electrical experiments with, and he sort of does low pressure, so you can actually see a torrent of electrified tornado, so to speak.
You want me to pull some up?
Well, I'm sure we'll get to that in a little bit, but I was just saying, seeing that and seeing the idea of these things being incandescent and then laying out across a landscape,
Right.
has I mean, especially when you consider the, when we went out looking there, like we talked about dinosaur bones and stuff like that, you find dinosaurs were shattered and spread out over a large area. I mean, what's that about? It's not like we would normally, like you expect them from like getting caught in a flood or something, right? So
Yeah, their bones are all piled up in piles, stacked together, like they were in a big storm and washed up.
So they get all piled up, and then like, what's are they mangled in between, like as if they tumbled or anything? Or can you tell? Is Andy still there?
Oh yeah, I think. Well, after they've been dug up, I think it's hard to tell. But what they find is a lot of these boneyards are just they're all in one area, very localized, like they were swept there by a flood or winds or something like that.
Mm-hmm.
But there's also anything else that we find is very disparate, though. Like it's just like I remember we were going with Robert out in Utah, and it was just like, and here's a dinosaur bone, and this is a piece of a vertebrae or something, and they were like, why did you find that so separate from everything else? Like, and we were talking about like Peter Mungo Jupp's idea of electric fossilization, but you put that together, like it seems that certain conditions create that. Like we don't find just petrified everything, a lot of times this stuff is severely damaged. So to find a pristine piece or a pile even of these bodies, some of them, like we were talking about before, fish that looked like they were still swimming. They were hit so instantly and turned to rocks so quickly. It's just fascinating. But anyway, I was just mentioning because of the
even though some of those dinosaur bones were actually of like semi-precious quality. I mean, that's how well they are.
Oh, really?
Yeah, the ones that I showed you.
Yeah, the little pieces that we found. We were at that. They were selling femurs for like $5,000 and stuff. And then
that was at the Ottinger's rock shop in Moab. But I'm talking about the ones I showed you on our property that were given by the other guy that had the pottery sherds from the Anasazi tribe.
Oh.
Yeah, we received a whole bunch of those from him because he had like a private land. He collected them, sold them, but he's retired now, and he gave us his collection. That's one I showed you, and I think they were from the Four Corners area.
It's just you can see the clear devastation of the American Southwest. How could you not wake up every morning and look at this? I guess is what my preface into Andy Hall's work was. Just right. My segue was long and boring. I'm sorry, but here I am.
Right. So and also, Andy, I had a bad connection there earlier. I wanted to thank you for that article you wrote for my rock. It was like I added to it a little bit and gave you credit there. So I just wanted to publicly say thank you for it. I really appreciate it. It was well written. Thank you so much.
Oh, I'm happy to do it. Are the rocks for sale?
We're getting ready to go to the Denver show this year, and then we're going to be getting splashing out for the holiday season. So we're going to have some touchstones ready with the Thunderbolts Squatterman logo on them, ready to go. We're going to try to get them on the Stickman on Stone site, or have a link available, possibly, or something going for the holiday season here, so everybody can get a piece and share some with their friends and their family members.
Nice.
That's good. That's cool.
That's awesome.
Yeah. I could put up a link to the the revised article, I guess, with all the input from the photographs and references and stuff. Pull it up here.
Yeah, I'd like to see it.
Yeah.
We also got. We were looking at. I don't know if you had talked to Edwin recently, but we had some great chats. He's usually on here. I'm actually surprised he's not here. He was looking forward to, or hopefully, I think that he was looking forward to coming to see you, or talk to you today. But we were talking about his ideas behind fossilization, how he noticed that certain elements look like two elements fused together, like two oxygens make was it silicon, I think? And you can see how certain molecules would, if we could get a fusion process to combine the nuclei, they would just be just two of them almost just perfectly together, and how there seems to be a system between the properties of fossilized stone and biological matter, how it's just a fusion that seemed to have changed them. That's what fossilized them instantly. The electricity was of that magnitude. And just coming to terms with that, seeing the idea of instant fossilization, but still, without further ado, can you tell us about, I guess, what was your talk about there on the 2017? I mean, I know it was about your loops idea, the prominences. Have you come up with what is new on your agenda? What have you been thinking about? What has caught your eye?
Well, you're on upheaval dome, so maybe we could start. Just look. Well, it just disappeared. The picture of upheaval. But what I could talk about is I've been looking mainly at the American Southwest and the Colorado Plateau. In this area here, I'm getting an echo, though.
Oh. Can you hear me still?
Yeah, I hear you fine. I just heard my voice echo.
Oh, just everybody make sure that you're muted, unless you're on headphones or something.
So I started looking. What I'm seeing on the landscape are the wind patterns, and mountains have a dune shape, and in EU theory, we've talked about that a lot. The ski slope and then the sharp backside to a dune shape of windblown dune, and most mountains exhibit that. And so I'm trying to understand the winds that created it and what caused the winds. And what I've seen, of course, going back to a couple of years ago when I presented at EU conference, I talked about the idea of arc blasts creating winds that were supersonic and showing evidence of the supersonic waveforms on mountainsides, right?
Yeah, not just the electrical etching, like the filaments burning across the landscape, like ripping up material. Like some of these look like the feathering there. Some of those look like that, but more of a deposition where you get the incandescent winds or mud, but probably incandescent the way it looked, coming in and welding together, so to speak.
Well, basically welding the material together. And so I was looking at that, and we went to this trip to the San Rafael Reef, and things started to become very apparent after I went to San Rafael Reef, because I started looking at the form of it. And if you want to go, do you know where the San Rafael Reef is? Up to the a little bit to the northwest of where you're at now, and we could look at it.
Okay. Just navigate me.
Stop right there. Stop there. Go to Green. Okay. See where Green River is, kind of center on Capitol Reef, Green River area there. Okay, so the San Rafael Reef is this D-shaped form on the land. This D-shaped, it's a big plateau is what it is. It's built up on top of the Colorado Plateau, so it's like a layer of cake on top of another layer cake. And so if you look at the southern rim of the plateau, it looks like sort of like shark's teeth. That is the San Rafael Reef, and that's a windblown form. That's if you can, pardon me, zoom in there just a little to the northeast of Hanksville, along that the rocky edge right there. That's the San Rafael Reef. And as you can see, it's like a bunch of shark's teeth going along there. They're triangular buttresses, and those are wind formed by supersonic winds and highly energetic. So these winds are forming shock waves, and the shock waves are basically reflecting off the land and creating those shock patterns. And with the shock waves flows a lot of electricity, because we're talking about an electrified environment when the atmosphere is ionizing. So I looked at this feature and tried to understand what would create it. And eventually it became apparent that this was created by an updraft of winds that was sucking material up like into a tornado and creating this rim along the edge where the shock wave reflected off the land, and then depositing this mesa, this plateau behind it that has this sort of D-shaped form to it. And then later on, in this huge electric field, there was etching that ate away much of the center of this rim. And you can see that's right where your pointer is. That's the eaten away area right in there. It's all etched throughout there and throughout the middle of the dome.
You could see the crisscrossing.
You can see the crisscrossing patterns and everything exactly.
That's so damning sometimes. I don't know why people don't notice that before. It's like you can't have two rivers crossing, but anyway, go on.
The rivers do all kinds of funny things.
Yeah, I bet.
Yeah. Wow.
There was one place in the San Rafael Reef that Bruce Laybourne and I walked through where the canyon came from either side up to a point we met. But there you were inside canyon walls. There was no watershed to create the canyon that we were in, if you know what I mean, because it flowed downhill in both directions. Anyway, there's all kinds of anomalous things out there with the rivers and streams as they cut through the mesas and mountains. They don't make a lot of sense from an erosional standpoint because you can't see where did all the stuff that was eroded away, where did it go? It would have piled up somewhere and you can't find it.
Mm-hmm.
So if you back up now to an aerial view of this, let me show you what I theorize is going on here. And stop there.
Okay.
Okay. So you see where it says Capitol Reef National Park. That's right at the very northern end of the San Rafael swell. That's the dome that's built up. And immediately to the left of where it says Capitol Reef National Park, there is an identical landform. It's a D-shaped landform that's formed by the river, which is a subsidiary of the Green River, and then Capitol Reef itself, which is another shark tooth mountain form on the backside of this landform where it goes, it is Capitol Reef, and it runs from where it says Capitol Reef National Park up to Glen Canyon National Recreation Area.
Yes.
You see a sort of a thin, wiggly line. Well, if you zero in on that, that's Capitol Reef. And you can see it has the same sort of shark's tooth pattern along it, especially on the right-hand side. That is another wind-blown, supersonic, wind-blown land feature that's created by a reflected shock wave. So it's on the backside. The wind is blowing from the south and creating that ridge line. And the ridge line around the San Rafael Reef is also blown from the south. So what I'm seeing is that this sort of D-shaped form that circles around you get the reef in the back, and then it circles around where Hanksville is and the river that forms the D shape. That is a downblast crater. That entire feature is formed from downblasting winds, whereas next to it, the San Rafael Reef was formed by uplifting winds.
Yes.
So what you have is a looping current, a looping wind current, a looping jet stream that's going up one side and then coming back down and forming these two. It almost looks like a pair of eyeglasses, right? If you look at them together.
Mm-hmm.
That's formed by a loop. And that loop is made by the magnetic field of the Earth. I mean, this is just a loop of magnetic flux. It's emanating out of the Earth and and then it's creating storms above. And one storm is a giant thunderstorm that's sucking up from the land. Thunderstorms have a central updraft. And then cyclones have a central downdraft that blow down. So what you have is two ends of a loop with storms at either end, and one is a downdraft cyclone, the other is an updraft mesocyclone. Now these storms are huge, of course, and they're sucking and blowing supersonic winds to create these landforms.
Well, if we give I'm sorry for interrupting. If we give anybody an idea, you can get a major storm can have a low pressure system below it that can raise the water like 50 feet. There's such a low pressure here that it's ripping the land off the ground. So there's clearly, it is like it should be almost described as almost like prominences, like a loop that you would see on the sun. I mean, for that, of the magnitude it would probably be at is what I'm thinking. But
you're exactly right. That's what I see. Is it's the self-same form electrically that we see being produced on the sun that creates the prominences or coronal loops. And I believe it's due to capacitance in the atmospheric layer and the crustal layer of the planets, whether it's Earth or Jupiter or the Sun or Saturn. I believe there's capacitance in the layer of atmosphere and crust through which these coronal loops are looping. And they're looping out because of capacitance in the circuit. And so it creates this form by producing a biblical storm, or beyond biblical, if you will. It would be a storm like what we see on Jupiter. So I started looking close at Jupiter, and I realized that the storm in the Great Red Spot on Jupiter, it's a stationary storm. And it stays, it's been there for 350 years. We've been watching it with telescopes, and we know it's been in the same spot. Well, I started looking at the features close of Jupiter from NASA images, and it shows the updraft and downdraft features of looping coronal storms in the eye of Jupiter, in the Great Red Spot of Jupiter. And so I started studying these things and realized that I was seeing exactly the same thing, I believe, that formed the American Southwest. And I started tracking features besides the San Rafael Reef. Monument Valley, for instance, is another uplift dome, and next to it is a downdraft crater. And I started looking around, and there is a pattern of these things all around the Colorado Plateau. And the Colorado Plateau, in my opinion, is built by a storm that looks virtually like the Great Red Spot on Jupiter does today.
Okay. Wow.
Very cool.
So what I've done is I started mapping out all the wind ridges. So these supersonic winds, when they hit land and form a shock wave, they form those triangular buttresses or dragon's teeth or shark's teeth type features. And conventional science calls them monoclines, and they're considered to be an uplift of the land. It breaks the land along the fault to create those monoclines. But I'm saying they're wind form from shock waves. So I started mapping them and creating a wind map all around the American Southwest. And an image appears that is, according to the wind map, shows the same kind of features that I'm seeing on the Great Red Spot. Of course, on the Great Red Spot, I'm looking at the cloud tops. And when I look here at the American Southwest, I'm looking at the surface winds and the features that they left. But the key is you can see the up and downs of domes and craters all over the land. And once I mapped the wind map, and then I added the up and down draft areas, it all sort of added up into a big, huge multi-vortex storm system that looks like the Great Red Spot. So I'm trying to write an article now. I'm not finished with it, but a series of articles that take you through and explain this and show some of the more impressive details that I've seen that show that this is very much like a storm system that was on the Great Red Spot that created all these landforms and created the mountains, the Rockies, and everything else.
And it would be, and of course, some of them, just like anything else, could probably, it wouldn't be, I mean, it seemed like an event, obviously, not something that was sustained constantly. Obviously, the Earth has gone through some apparent devastating episodes in the past. We don't know exactly when they all are, but you got a chance to go up past the Three Fingers. I went with Robert. We climbed up that canyon. We climbed one of the monoclines, too.
Oh, yeah, up Three Fingers, yeah.
So we went all the way to the back. We found a petrified tree back there. Now, part of me was sitting there going, okay, well, this tree was knocked over, and there was a cliff, an actual cliff back there that was just straight up pretty much. And it looked like, just from that, especially walking from the back to the front, you could see where it looked like debris had smashed into this thing and then started piling up. And like, I mean, we're talking 70 degree angles from, like almost perfectly
Pretty
vertical.
much.
And it just kept layering and layering. You could see things were slamming into it. Things were wearing off the top, rounding some parts off because you could see, but other things were slamming and sticking in the layers that they came, it seemed. And it was, the sheer magnitude of it to understand what you were looking at.
What I'm seeing are the forces that were. The way I look at it is what we're looking at is like the top veneer, the top layer of, the most recent event and beneath that are layers upon layers, I think, of previous events. So if you consider this as like a weather system, only it was created, way back in primordial times, and I assume it was before mankind lived on the earth. There were these primordial storms that created the landscape, and they were recurring storms. Now, what made them recur, I don't know. Whether those were solar events that charged up the solar environment, or whether they were due to Venus being out of place, out of orbit, or
a la Velikovsky, yes.
A la Velikovsky. Some event caused these storms to jack up, and then over time they recurred. And I think today we see exactly the same thing, the same weather events, only they're just a very less severe events than what happened in the past. And I think the biblical events and the events of mythology are recording much more severe storms that happened in the past over time that mankind did witness. They didn't necessarily make the mountains, but they probably did rose a lot of havoc and probably caused mass extinctions or nearly so.
Well, we were talking just recently how that there was clear evidence that a comet, for example, or some sort of massive disaster took Europe by storm in around 535, and how Rome was found buried under debris, that type of thing, where these, like, why, how could you have 40 feet of dirt on top of a city? Like, when did this happen? Why did anyone notice this? Why isn't this written down somewhere?
You mentioned that, Neil. One of my readers wrote to me, and I chatted with him for some time, and he was showing me around St. Petersburg.
Yes.
In Russia. The buildings, the lower floor of the buildings are buried halfway under, like 7 feet of sediments. And there's no explanation anywhere for why that is. And it's like they didn't build them that way. They have, their windows are underground. And it's just very strange.
Oh God! I think I saw that exact video that he's referencing, and I apparently, from what I heard, they said, was it made by a flood? That was a good question. So they did a drilling, because once someone realized what was going on, they did a drilling right in the street type of thing, and they realized that the street was below. They found the real street, like the first floor street, but on top of that first floor street was like a crushed layer of snow. So this happened during the wintertime. There was no water that fell on top of this. Like, it was like ash from a volcano or something, like would just kept burning and burning up. But it wasn't ash, obviously, it was dirt. I have no explanation either. It's very...
But some of the buildings,
Bizarre.
There may be 300 or 400 years old. They've been around for a while, but still, there's no
record.
Record of where all this sediment.
Do we just push this aside? Like, oh, God punished this area. Let's not talk about it. I mean, is Sodom and Gomorrah the only one we're allowed to reference? Like, I'm just asking. I don't know. I have no idea. It's very weird.
Well, one could imagine, if you were a conspiracy theorist like me, one could imagine in a disinformation campaign against us.
Yeah.
Well, don't start talking crazy. Next, you'll
What's
go
the-
on about
what's the-
Bigfoot.
Yeah. I mean, we've discussed
I'm
it
just
before.
kidding. Just having fun with you.
The layers of mud in Europe and when the time frame. I mean, I remember Heather mentioning and knowing some detail about it, and Neil as well. Can we rehash that a little bit, because it's pretty interesting?
What part exactly?
I actually had sorry.
Oh, go ahead, Robert. No.
I just before we get off topic, I wanted to talk about that delta pattern that Andy was talking about, because I had a formation in some of my rocks that I wanted to share.
Yeah. Everyone.
Okay.
Yeah.
Just before we get off on
before
that.
we go into St. Petersburg and
Before we go to St. Petersburg, right?
Right.
Okay. Yeah. There's a rabbit hole there for sure.
I love
Yeah, but
those
can we
rabbit
come
holes.
back to it? Because can we come back to that though? Because I did have a few things that.
I was interested to hear
You know-
what you had to say. So yes, you definitely.
Okay.
We'll
You
definitely
first,
do.
though, Robert. Definitely.
Oh, thanks.
Let's
Okay, you
do
mind if
that.
I share take the screen?
Yeah. Do it.
Okay. So
Robert
Sure.
is so demanding. We're just going to have to deal with
I'm
him.
sorry I asked.
It's just okay, man. It's all
Oh.
good.
We tolerate him.
All right, so I got some 706 here.
We tolerate
This is
each
one of
other.
the pictures of the rock that I have
Somewhat.
here. That this is a blown up picture, but you know that one with the two nodes, Andy? I mean, Neil, with the concave one that I had at the exhibit.
Yes, yeah, I remember you showed
Okay.
little loops right on the rock. It looked like
Right.
the
These
little
are this
Ds.
is a blown up picture of that delta pattern of the crystals that are. These are like crystal fat that's forming on the stone here, which is basically a nalcium and a calcite. And so here's like your delta pattern here, and this is a more inverted version, but it's a smoother pattern. You can actually see it here. But I also took an overexposure with a higher flash on it, and let's see if I can find it here. There, you see it. You can actually see it a little better here, but I'm sorry, I'm tethering on. But can you see it here? Like this is your butterfly pattern here. Can everybody see that?
I think he's talking to you,
Hello?
Andy.
Sorry, I forget to undo the mute. Yeah, I do see the pattern. I don't
Okay.
think this is related to supersonic winds in that sense. I can't. Looks like it's a very small. That's a small rock.
Yeah, it's
right?
a smaller version. Yeah. This was about a 30-pound rock, and it had those two nodes on it. If you remember at the exhibit, I had it under the flashlight with the magnifying glass because it had like those two geodes in a dish. And,
Oh, yeah.
And then I found these little crystal formations on the side. You can see where the crystal actually comes in the rock because it's separate. That's why I took a better picture of that. But this would be that right-facing wing, and then right in here is that left-facing one where it's a little bit lesser. But they're both delta patterns, and they're kind of inverted. So I was thinking that maybe this was a smaller scale version of what you were talking about, but something zorked this rock is basically what I was saying.
What I see is that the shock waves, after they form and they start to lose energy, they start to dissipate, and they kind of like wiggle around into different shapes. And when they get real small, they're sort of just like wiggly lines that are actually lines of current through the rock, I believe, following the seams that were created by the original shock waves. But they don't continue to form the diamond patterns once they get very small. I think this might be these patterns are the patterns of crystallization that may have some, electrical formation for sure, but I don't think it's the wind form.
Well, remember when you saw that the lead up right to that where Robert found that you and Robert, I think, and later me and Robert found some black stuff oozing out of the rock. But if you look right up to that crevasse this is back in the San Rafael Swell area, you can see the crisscrossing patterns in the rock. Like it looked like electricity was leading right up to that spot, like it blew it out
Oh,
or
yeah.
something. I think you put it, you referenced it in your article, Andy, so I knew you were there.
Yeah. Oh, absolutely. That was, I think, in that Three Fingers Canyon, and there was the side canyon, and it was a real long, narrow side canyon.
That was one of. That was the one that was a little bit further south because it had that large, what Bruce called the Dragon Egg, which was like a fulgurite tube, and that was a little bit further south than Three Fingers. That was a separate site.
Oh, okay. Well, in any case, that was one that we went into, and in the back of it there was this hole with black stuff oozing out of it.
Right.
That was hardened. Yeah.
It was all hardened, and it looked to me like an arc emanated from there, and then it was followed by this effluvia of foaming gunk.
Well, yeah, it feels that way. Yeah, like there was like some sort of transmutation or something that was at the culmination point. And that dragon egg was beautiful. I got some really beautiful shots of that.
Yeah, I think if we were able to analyze the rock and do real forensic analysis of it, had the tools and skills, which I don't have to do, but I think if we did, we would find it would be electrically altered. It would be like depleted of electrons or certain elements that would show that it was electrically depleted in some way.
I can envision this. I remember just thinking about how much this affected geology to the point where like all of the theory stuff has to be sort of cut off and redirected, or at least added to significantly, because the older geological stuff where you notice patterns, which is more of an interpretive science, that stuff is still real because we still find, like, this is when you see this type of rock, it's a good spot to find oil, or if you see this type of thing, this is where you're going to find gold, or that type of stuff. The stuff that you learned, without the theory, just interpret what you see. This type of tree, that type of fruit, type of thing. But that's the canyon.
Hey, Neil, I sorry to interrupt, but I think that's a slot canyon or one just like it.
Yes, that's exactly the one. Yeah. That's Larry White right there. That's a picture that I think either you or Bruce took.
Yeah.
So this is that effluvia that you're talking about. And this is a rather steep slope. This doesn't look like rather narrow from the photograph. It's pretty steep, if Neil remembers.
Oh,
it's on slick rock too.
There's video from what we have on this. That's in the thing. I'll link it. But walking through that, I was taking feels a little bit like you're taking your life into your own hands sometimes going through some of this stuff.
Yeah, and all up along this edge of this wall was what Neil was talking about. It looks like something like current was just flowing right through it because it left a scar, and it really concentrates up here, right where this blast is.
It sort of brings to mind, Neil, what we saw in the West Fork of Oak Creek Canyon, or was it the East Fork?
Whichever. It was West Forks.
West Fork. That, that snake-like shape in the bottom of the canyon, and then that flame out in the rock that was just impressed in the rock.
Yes.
This slot canyon is very much like it, an arc form, blasted out of that.
It's like the... Well, when you see those type of cuts in the rock and stuff, it's especially when now that you've helped me so much. One of the things I've noticed now is when I see rock fractured, I go, well, this is probably supersonic. Like I see stuff like that. How is it fractured up there but still welded down here as one rock? That type of thing. Oddities it shouldn't be, because it should just fracture and fall off, but it didn't. It's fractured and still welded. Those type of things. Why? It's
and another curious thing when you mention that, you see these fractures and you see veins in rocks, and what I see are the shock patterns that are
exactly.
And the shock patterns that current flowed through and then created like quartz in those veins as a result of that electricity diffusing through there and creating crystal from the silica. And what mainstream says, of course, is they'll take a rock full of veins like that they say, well, it was formed, 70 kilometers below the Earth, where the pressures and temperatures were adequate to make this rock form. And they measure everything on a time, temperature, pressure scale without using electricity as a bonding, mechanism. And so they interpret everything in terms of millions and billions of years and how deep it formed beneath the Earth. And then you look at these rocks and you see their fractured nature, and I just wonder, well, how did they rise to the surface without crumbling to dust? I mean, how did they go through all this evolution of churning the Earth, through subduction and stretching and erosion and all this stuff happened, and yet you have these huge rocks, whole mountain forms of cliff faces that are veined and crisscrossed with faulting, and yet they didn't break up coming to the surface somehow through all those different forces. They still remain intact. And to me, if the Earth were made the way the mainstream scientists say it was made, it would all just be a bunch of pulverized dust. I don't think we'd have. Anyway, that's.
No, you get a good point.
Right.
You got a good point. We constantly complain of the short-sightedness of not taking everything into account, because clearly, I mean, there are forces that will, the advantage, of course, with electricity is it has that nature of being able to sort of bring things together and create as well as destroy. It's a two-way street, so to speak, compared to most things. But the heat thing, when they're talking about fossils, I just, interestingly enough, there was an article just recently where they put out they said, they found a way to make fossils really quickly. And it's like, oh, okay, how'd they do it? We went and read, and what they do is they take sand and they superheat and put the animal that they're going to fossilize in between this, and they superheat it to try to get that to bond with the stone. And you're thinking to yourself, so you don't think that this could have any effect on how it actually happens in real life? They didn't make that connection, but they said this will imitate billions of years. Oh, okay.
Yeah, they ought to pass a current through that.
Exactly.
Right. Well, that reminds me a lot of like David and I were just talking about mocha megani, which is layered non-ferrous steel that's kind of like made to look like wood grain. It's a Japanese metal.
Right. Yeah.
I don't know. Way to make jewelry. And in
Very
order
beautiful.
to do that, you can't weld. First of all, you can't weld non-ferrous material, and you can't weld things together that aren't the same material. So you could, you know what I mean? You can't. They're going to keep their original composition and personality, but you can heat them up to a point. So what you do is you layer them on top of one another, alternating, and then you bind them together really tight, and then you put them in. You heat them to they're just above their melting temperatures, where they're super red hot, and all of their molecules are separated. And then you hit them one good hard time, and you better hit them hard so that all of those layers meld together. It isn't welding; it's like a form of diffusion. You're fusing them together, and then after that, you can start to pound them down, and they will remain solidified in their layers. But that one good hard boom. And they're one solid piece, and now you've got like a tiger stripe, of layers. And then as their holes are, so like you flatten them out, and you make that whole cookie, say you make that whole thing smaller, and then as it gets dents in the surface or imperfections, any kind of material is removed, and then it's compressed further and further down. The material from underneath is allowed to go up through those spaces, those empty spaces, and create these ringing effects, these layers, the holes. You see it often in rocks and stuff. So it was like, for a long time, I'm like, how if it, instantaneous fossilization, this instantaneous transmutation that we're doing in a metallic process for making jewelry. And that's basically the same idea of how I envision it is what's happening under the ground when they put these, or when they instantaneously fossilize these animals, or these layers become fused. It's like they're all heated and to the point where they're just on the verge of liquefaction. They're just about to turn liquid, and then suddenly a huge amount of pressure is pushed down, and they're condensed together, but they still maintain themselves, their personality. So you'd still see that it's calcium. It might be calcium carbonate. The silicate might have been turned into something else, but when you break it down in the molecules, you can see that. Or they become completely changed into something new because their melting point did change their state of matter. They did become a liquid. They did become a gas in that instant. And then when that pressure pushed down on it, it was changed. So that's a supporting evidence of a long-known material process that supports these ideas, and to show this could be happening in gigantically in the surface of the earth around these types of huge impact, discharge, plasma discharges, huge heat, huge pressure, instantaneous boom.
Andy was literally like we were lucky enough to have a talk about this before. The crystals and stuff in I suppose also in metals, but piezoelectricity, when you have such a pressure hitting something, there's an electrical aspect to a shock wave. Is there not, Andy? That you've mentioned. We were talking about that before. The ability to, because we had a debate one time about a rock dike and how it was formed, for example, around shiprock, that type of thing. And
in a shock wave, if you form a shock wave with an explosive, it will form. The shock wave will it has higher density, and it will ionize within the shock wave. So you get this ionization from whatever ambient ions are pressed together into the density of the shock wave, but then you have collisions going on and the high pressure and temperature in the shock wave that creates more ionization. So like a nuclear bomb will create a shock wave that will actually shoot lightning. It will arc lightning bolts out of it. And that's been witnessed. And that electrical charge is the shock wave itself generating electricity in itself. And so if you have supersonic winds, the same thing can happen in the presence of some ionization events going on. And of course, like a big storm like this, there's a lot of ionization going on because the air, you've got an air gap between the clouds and the ground that we see lightning in now. That air gap is ionizing, and arcs are being generated across it. And so that's what a shock wave would do. It would create arcs in it and flow current through it. And I can imagine like a reflected shock wave creating a sheet of current through the atmosphere. And then any dust that's blowing into that is getting electrified as well as being compressed, pressure and temperature density wise being pushed together. And but the electricity is present too. And I think that's probably the more key element in fusing the rocks together and crystallizing the rocks.
I was always thinking about the way that since we were talking about that, just the idea of a force hitting it, and all the energy would not just be dispersed in the aspect of kinetic energy, and it would not just be transferred into heat, but because of the piezoelectrics and the other materials, and the idea of telluric currents, so to speak, running across materials in the boundary layers, as we mentioned before, where you're going to, if you have a choice between, you can't run through the calcium carbonate because it's pretty much an insulator, but the iron-bearing sandstone, for example, that landed on top of it, you'd have a thin layer where it would run across, and you're hitting that with more and more force. The crystals inside, of course, some of them being formed just recently from the lightning bolts going through them, are now just, pulsing with energy as they keep on getting slammed. This type of idea, and what it could mean for, how the process of welding these things up there, these buttresses and so forth, is Well, it's a whole brand new avenue, really.
So,
sorry.
no, I was gonna. You were talking about bonding the metals together, and I wanted to add that titanium acts like this. I mean, if you take titanium, and titanium forms a titanium oxide on its skin very easily, almost immediately. But if you can eliminate the titanium oxide from 2 plates of titanium and then press them together, they'll actually bond. And it takes a little bit of pressure, but it doesn't even take temperature. You can take 2 sheets of raw titanium without the oxide having formed, and instead of forming an oxide, the sheets will essentially weld together, cold weld themselves together or bond together.
That was something we talked about. Space had an issue. There's some of your loops, by the way. You're just showing how one was just picking up and looping over there. It was kind of neat.
Well, his experiments, I've been watching his. These are great because although this one doesn't show it, some of his other shots show that he has a nail in the bottom of the glass, I guess, and then the sand piled over it, and then an electrode up at the top of the bottle, at the neck of the bottle. And so the charge is coming up through the sand, and as it comes up through the sand, it arcs. But then when it leaves the sand into the atmosphere, it becomes a dark current. And you can see matter being lifted up in little vortexes swirling up. But you don't see the current because it's dark. Once in a while, it'll pop into a glow mode or arc. But the arcing's taking place down in the sand where it has the crystalline form to flow through, I think. And that's, if you imagine an electric current, a capacitive current being impressed through the earth and sky, you would see the same thing. I think you would see more arcing in the ground than you would see in the air.
We were talking about that. Yeah, the idea of vugs and quartz coming in veins and that type of thing. Just when we walked across Bryce Canyon there, we saw all the dead trees along the rim. There's something going on. This is where it's going for the edges. I have this vision of the canyon lands, or not canyons. The vision of the scab lands. I think it's in Oregon or Washington. Just how it's all how it moves. How you can imagine you wouldn't think of a mesa being formed and then moving across the land. Until, and picking up what it just made and then dumping it over there, so it's so chaotic, but it has a system. It has a pattern, and it's no matter what, you could always look at a picture of the moon and know it's the real moon, not just because it looks wrong if someone tried to paint it or whatever, because electricity has certain patterns it makes, and then we just recognize them. We don't even realize we're recognizing them. This was one of those. Go on. Sorry.
Oh, it's so natural. It's so natural, and we always see that. And looking at these and seeing all of these things is like this is exactly. Andy, can we look at the Eye of Africa with you?
We can look at which now?
The Eye of Africa.
Oh, absolutely.
Research.
That's one of my favorites.
Can you pull that up, Dave?
Yeah, would you mind pulling that up, Dave? Because it actually is what Jacob Gable just made in a bottle is exactly the same as the Eye of Africa. And then there's all these amazing littler, smaller discharge areas around it. So we were looking at it yesterday, Richard and David and I, and we were looking at the areas north and south of it. We were looking at this hole above it, like a big cave crater thing above it, that dark spot, like the in and the out and the D shape, and then the all the little spaces around it. We found like one that looks like the Hawaiian Islands, a chain of discharges that looks like the Hawaiian Islands in a way.
Oh, you'll have to show me the Hawaiian Islands. I haven't seen that, but I've looked at this. I'm still studying it a little bit, but if you zoom in on it, you can see that the rings themselves are formed by shock waves. Those are, in my opinion, supersonic shock waves around a vortex that was
pulling in.
Pulling in, exactly. And so you can see that, and the triangular formation is only apparent in certain places. And in other places, the small ridge lines are smooth. So that indicates to me that it was partly subsonic winds, but they were still very strong winds that were pulling in around this thing. And it appears to me that there's some rotation to it too. And then you can see right below your cursor, the cuts in the rock, how they are pointed sort of towards the rim of those cuts right there. Those are all shockwave formations there. And so that's sort of starting to form the reflected shockwave teeth, the buttresses.
I was mentioning that to a friend of mine when he said, "Oh, no, it's a dome that has uplifted and worn away." And I was like, okay. Have you noticed those little things that you just pointed out, how they're going around in a spiral? They're all pointing the same direction. They're trying to go around this thing. They're going along with the wind. But
exactly.
He deliberately had to ignore that. Like, you have to ignore so much stuff to get to the story that they are trying to purport. And I don't mean to be mean to them, but come on.
But they look like cogs. Like, it's like that spinning motion is being pushed in a certain direction and catching on these things like a whirligig, and just kind of, you know what I mean, like scooping that circular pattern out of the ground.
Yeah, and I think there was just a real intense electric field over this spot, and if you look at the sand formations on either side are like two big rivers of sand in this North Africa region, and to the north, it appears to me that the dunes are aimed one way, and to the south they're aimed the opposite way. So this appears to me like it sits between two shear winds, one going one way, one going east, one going west, and this is spinning in between these winds. So if you go out on the sand dunes off to the distance to the north and south of this, you'll see the dunes, and it appears to me that they're formed by winds that were flowing in two different directions through here. And that ridge line and the feature itself, the eye, are formed in the shear wind and the shear zone between those winds. That's what I think. Now, I have to say, I've been spending my time looking mostly at the Colorado Plateau, and I've kind of only given a cursory examination to this, but that's what I saw at first glance.
It also looks like it could be, cross section of a Berkman current with the rotation.
Yes, definitely.
Well, these coronal loops are essentially that. If you have a coronal loop looping up and out and then back into the earth, it's basically forming a big current loop. And it's, I don't know if technically you would call it a Berkman current, because when I listen to Don Scott, he talks about a force-free environment, and this would not be a force-free environment, but it would be but you would have a current that would be following this magnetic flux, induced current that would create these loops and contact the ground at a point like this, and then probably be contacting the ground at another point, perhaps that big black arc feature that's to the north of this.
Yeah, that's what I was about. I wanted to ask you how you felt about that feature just north of here.
It appears they could be related, and I can't say that for sure, but it certainly would make sense that this would be the other end of the loop, and it was in arc mode or a very hot plasma mode, because you can see it's just charred. And I'm sure that by mainstream convention, this is probably a volcanic feature, but I believe it's an arc created feature.
That makes a lot of sense.
David, can we scroll back down to it though? Can we go back down to the one you were just looking at?
This one.
No, the one further north, the bigger one.
Yeah.
That one. We scroll into that one, and then 2 features just north of it. Not so far, I guess.
Oh, that's beautiful. No, it just looks like black etched rock, you know? Like, could you imagine going through a black canyon like that or whatever?
You can see the lines drawn straight through it, but if you go just northwest, okay, that swirly one that we were talking about, and then right of it are the Hawaiian Islands. Okay, so there's,
And it's
but
also...
remember how...
Go ahead. I was just going to say, it's interesting that the eye structure also has a crater like that one off to the side, but it's not a mountain, it's a crater. Like a smaller crater. So it's like it has a pair, just like this is a pair. You know, because I remember if you look at prominences, how they come out they have strands, not just one strand. There's a loop, and then there's sort of filaments in the strands. And you know, once you can break down that layer and get a full connection to the circuit, what you're really doing is you're eliminating the dielectric strength of the air itself. Like if you could put so much material in the air that the air becomes a conductor as opposed to, or the pressure changes so much that it does this, you know, you can envision that you're able to move material much more efficiently. And of course, if there's, you know, something happening, these currents, I mean, it's going to want to come up and then go back around to where it's coming up from. Like it's underneath the ground. All of this, like there's the earth itself is going to like, oh, here's charge coming back in, because these are secondary currents essentially. They're not the full, whatever was going on the earth was bigger than these particular events. Like, you know, like it was at the point of this, it was almost completely immersed in fire. If anyone was alive to see it, it would have been world ending, you know.
I think when these things were happening, whatever life was on Earth was virtually eliminated and probably started over from pond scum and had to start over again. So this, what you were mentioning, Neil, is that you know, you get these strands, and so you have like what I call fractal repetition of the form. If you look around the San Rafael Reef too, you see the dome of the reef, but then the reef, and the dome inside of it. But then around the edges of it, you see additional little domes and craters, because these loops are fractally repeating themselves at different harmonic scales. And the smaller they get, it seems the more intense they are as far as charge density, because you can see the result on the land. Like this one is burnt from a hot ox.
There's another crater around there.
Now that's also showing dikes that are either dikes or they're a scratch across the surface. You know, it looks like a crater chain almost between some of these craters, but I think they may be dikes where charge shot through the land, similar to the dikes that emanate out of shiprock.
Yep.
These, I think, you can see the lines flowing from the big feature, the big black feature, towards the smaller feature off to the side. You can see the lines going through there, and those appear to be dikes to me, where current flowed in the landscape.
They could have been like boom, made at the first hand and sort of covered up by sand, of course. I thought I saw a couple right on the Black Ridge there itself, but also I noticed, if you stay right there for a sec, Dave, if you notice, that looks, and this is just me, I'm not picturing that the black area to the left is a pit, but it is a mountain. That's just my interpretation from what I'm looking at. But those strands running off of it, if you notice, they're running the ones that look like water erosion. Like on this slope here.
Sorry, go back.
Yeah. Oh, there it is. To the lower left there. The water erosion on that. Anyway, just stop. It's good. So, but anyway, they're in reverse patterns. They should be coming down off the mountain and then fanning out as they lose kinetic energy. That's the way that water works. But if you notice, they're fanned at the top and then they come to a channel. I just noticed that. I just indicating if anyone is sort of studies water, you'll notice that there are certain things that look like water, but probably aren't. There's probably
That's a very good observation. Yeah, and also the fact that they're like spiraled, as you know, that that idea you guys always talk about of it twisting, like pulling up the tablecloth, you know, and it's like pulling and twisting the tablecloth up as it's going. You know, do you see it? That motion effect, twist and pull the tablecloth.
Yes, I do. I see what you're saying. Yeah, and then it is actually, if you want to go even further, we can even show that if that black spot is a galaxy and that other black spot is a galaxy, this is not unlike the arms of galaxies reaching out and connecting to.
I love that, Neil. I love that.
Well, it's just an observation, but it's with new eyes, I guess. We're not taking geology to the next level there. So.
Hey, Dave, could you look up the Owl crater? I'll spell it for you. I can't ever say this right.
Okay.
Aouell.
Hold on one sec.
Yeah.
Aou.
Yeah, Aouell.
There it is.
There we go. Okay.
Oul. Yeah, that crater. Yeah, it should be right by the eye of the Sahara.
Oh. Oof. There's a little puff there. Poof.
It's almost hexagonal.
Yes, it is.
I've never seen this before.
Yeah, this was mentioned in the letter from the University of Pittsburgh from Bill Cassidy. They compared Upheaval Dome to this crater in Mauritania. So, and I actually thought that this was the Richat structure initially until I had to look them both up. But I never could say this right. But I wanted to check this out, see if you guys had ever seen this one before.
Yeah.
I have not. No.
They're calling it meteorite.
Yeah.
Well, as Andy and I can attest, you can go everywhere, but there's no meteorites.
Yeah. Right.
I mean, some things fall to Earth. But
that tint, the tint is pretty strong. I'm wondering if it's just the.
I think it's clouds. They took a picture where the clouds.
Yeah, it's right along that. I mean, that might be the seam that they use. But it's just interesting.
But yeah, Andy was talking about those little. Anyway, go on, Andy. I was just going to mention some of the interesting things that you noticed about off to the side of some of these major structures, little piles of dirt and stuff like that look like they were electrically concocted, so to speak.
Oh, go ahead. I was just going to agree with Robert saying it looks hexagonal. Across the bottom it does. It looks more rounded across the top, north end.
Yeah, so does some people.
But at the bottom, it definitely has this straight sides of the hexagon on the bottom half.
Mm-hmm.
And so does Upheaval Dome along that northern edges, because you got that riverbed where it goes out the northwest side, and on the northeast side it's kind of like blown out. But along the north edge, yeah, it is kind of linear, and then the whole bottom part of the hexagon is shown, just almost like Upheaval Dome. They're almost similar.
Wow, look at that! Look at that land right there, doesn't it? I mean, just where, like, for example, right near that crater, but just the whole striations all coming down. It looks just mangled with dust having landed on top of it, over time.
Totally.
What I find interesting though is that when you look right at that feature and you see how the sand blows and you see the streamers of sand dunes running between those fingers of rock, and you realize the rock fingers follow the wind pattern.
Yes.
Mm-hmm.
That's again also damning. We were. It's fine. It's really nice when you go and look at, like, recently they sent some pictures from inside one of the edges of a canyon or something where they sent the rover down into or something, and you're looking at that and there's never been any water here, and you can see it's just. I mean, I couldn't tell if I was in, American Southwest or I was on Mars. You can see the just like you showed, the fractured rock, that broken up into pieces like we saw in the West Forks, where it was like, no, we're going to break these rocks into pieces and try to lift them away, but I couldn't. I didn't have enough strength. That was just the end of a current, as opposed to, like, the main show was over there near the Grand Canyon. I'm just this the secondary effects, but still monumentally beautiful. And you were right, the fractal nature where it scales and keeps going down until just like you could see through Buddy's experiments, where he does the same thing with wood, where you see it burning across the landscape.
What was that? What was that structure that we were looking at? Was it Azerbaijan or up in that area with Edo? Neil, do you remember the name of that? I mean, I could probably find it because that's another big prominence. It's been pretty fascinating, right?
Well, while you're looking for that, we're going over to Europe anyway to take a look at St. Petersburg for the benefit of
sure. Since we're world travelers.
But Heather, you want to say something then about the area? He's going to look up a crater anyway. I don't even know exactly where it is, Azerbaijan or something. I remember him looking at a river and showing stuff in Germany. That's all I really remember, and he was showing about the water table or something. But speaking of which, as we know, because of the water levels dropping in certain areas, some of these petroglyphs and geoglyphs are becoming more and more prominent. So I think that's very interesting, and want to see where that's going to go in a few years. But so what was it, Heather, that you want to talk about?
Well, I just wanted to comment on marshy lands and and to first say that Rome was built on a swamp, so it's very susceptible to water table changes and therefore ground changes. Same as St. Petersburg, you could see where it was located. It was surrounded by water, and in a very short period of time, water with the moon can move land and take over things and places and bury stuff. I went to this lighthouse with my kids last month on Taos Point up north, and the lighthouse was built 100 years ago in the water on pylons 4 feet up, in 4 feet of water, and then the boats would come right up to the door and dock. And they just get off the boat and go straight into it. And now there's 2 miles of land with trees and little lakes and all this stuff past it. It's no longer a functional lighthouse in that sense because of how far away from the actual tip of the land it is. And that happened within 100 years. And the lake and the wind pull the sand from underneath the water and bring it up, and then it formed a sandbar that's just kind of building onto itself in this area. And when the water table is down, or when there's droughts and there's long periods without rain or snow, the water there can go down so far that it could be 3 miles of land. And then the next year, it goes back all the way up if it rains a lot or, whatever the situation might be. So every single year since I was a kid, you go there and it's different. It's a little bit different. And slowly the sand is, the land is being reclaimed by the land. It's just kind of taking, and it's going to eventually close itself in and make a lake there. And Detroit was also very similar. There's a lot of churches and other buildings, but mainly the churches are still standing. Why I mentioned them, but they were built at waterfront as well. And there's one place in particular, St. Anne's, down in southwest Detroit. It has Gabriel Richard. He's the patron saint of Detroit, I guess it would be.
I thought that was Eminem.
I thought it was Kid Rock. But he was buried, in the nave of the church, right at where the priest stands and gives the mass. They buried him as their what's it called? The I don't want to say trinket because that's not right, but that they have a holy relic. That's the word, the relic. And he was their relic, and he was buried there. And then the water would come up so often that eventually it pushed his coffin up from the floor, and it had to be reburied in a different place elsewhere. And then now that church stands at least 1.5 miles from the riverfront. And that, again, is within just a couple hundred years. So I could see an entire city being buried under 40 feet of silt within a generation or two. I can see that happening in those places where it collects. And right here, Detroit, you can see it's just marsh. There's so much water here. The water table is like you dig 2 feet anywhere there's water.
Well, I'm with you, except that if I'm not mistaken, it was called the Seven Hills or the Seven Sisters, is where Rome was. Portus was the the serving port for Rome, and that is completely in swamp now. You're absolutely right. In fact, only recently did we discover the canals and everything that they had to connect Rome to that port. And it looked like they had a system that was just, we thought it was just the river, but they had a system of canals and everything else that were connecting Portus. And you're right. It had reclaimed all of that land, all the way up to those hills, I guess. But there could have been storms and stuff that buried it. I don't know really. But what you're saying is not uncommon. I've actually, speaking of which, I want to point out to some of our viewers as well, and you people as well, everything. But there's a hit, instead of just the idea of buttresses building up from wind, we do know that there has been land that was literally lifted sideways. Now, I don't know if this was through the slow churn of geological time, but we've seen footprints that are like near vertical of dinosaurs walking across something. They found it was, in South America, a crew found it, but I'm almost inclined to think that given the forces involved, that chunks of land could have been dropped back down as well. So I give no understanding of exactly how that happened. So, but there is clearly something that has. Sometimes we find land that has actually gone up, but these are not the case. So you can see clearly because of the patterns and the buttresses that they're definitely a shockwave induced effect. So that just came to mind. So we're
right. Like it's important to differentiate because there's multiple causes to things, and you know what I mean. And then sometimes too, there's that domino effect where an electrical effect causes the water erosion, or like Andy keeps talking about the wind erosion. So it's important to understand how all of those kinds of things, and what is the cause in nature. Why does the land build up there? Why is it swamp? Because you think if all of Italy has to be kind of like Florida with sinkholes and they have volcanoes, I mean, their ground is like really unstable in that area. Anything could have happened. There's got to be a reason that there's a lot of electrical current.
There's that layer of silt, right? I mean, this is the one that kind of we were exploring a bit, right? There was a period where they went back in and they had to dig down into quite a deep. It was quite an excavation to get everything out, right? But to see things once again into the modern era, or quote unquote modern era.
Oh, you mean Rome?
That whole area, any of the archaeological treasures that we have these days, right?
Well, because look how it's like in a row of indentations. You've got Civita di Bergiano or whatever up here by Viterbo, and then right underneath of it. Wait, stop moving it, Dave.
Sorry, skewing our direction.
Just go slow and direct me. I will. I totally take direction. I attempt to take direction. Yeah.
But you see that this is actually good too because you can see the vertical line of it. So you can see this lake up here by there's one above Viterbo and one below Viterbo, and then you've got Rome, and then another one right below it. Stop moving it.
I can do. Slow down. I'm just
trying to illustrate that there are these divot points going down, and that Rome is right within that line of those low points. You see them?
Uh-huh.
And which I would think would make it geologically vulnerable.
Looks like a crater chain.
Yes, it does. And then there's
those mountains look amazing too. They look like they're almost like little squirrels themselves.
Yes, they do.
Like around Fluggy there.
Shouldn't the volcanoes though have a lot to do with all the lightning activity?
Yeah.
Volcanoes are extremely electric. They create, and different volcanoes are different, but some volcanoes produce tremendous amounts of lightning. and they'll even form like an anvil cloud, like a thunderstorm does, and shoot bolts of lightning out of that anvil cloud. And they've measured lightning from volcanoes like 100 miles away coming out of these big clouds.
I've
Big,
always
huge
wondered
positive
that.
lightning strikes.
Well, I was just thinking because Italy has been having a lot of lightning activity at the same time. Didn't Mount Etna go off this year?
Yeah.
Yeah.
I saw that. It's going off. It was going off now, right?
Yeah.
I believe so.
If you look at cloud formation, Heinrich Svenmark's done all this work, and I'm just citing him. But cloud formation starts with with particles getting ionized from cosmic rays. But if you imagine a volcano spitting a bunch of ionized material into the air, and we know that happens, that's why the sunsets are so pretty when there's a lot of volcanic activity. There's just a lot more ionization in the atmosphere, dust particles that are being hit by cosmic rays and ionized, and those then form aerosols that start collecting together because they're now charged, and they aggregate together and they start forming clouds. So there's a nucleation of the cloud from the ionization event, and then there's an aggregation because of the charge differentials, and then there's diffusion, and that's what we see when clouds form. I believe is diffusion of that charge through the atmosphere, through a layer of a moist layer. And if you take a volcano and put all that dust into the atmosphere, it's just going to enhance the opportunity, I think, for storm formation and especially electrical storms because of how much aerosol is in the air to be ionized and create a huge electrical event.
It's also interesting how no one even asked this, but it's critical to understand volcanoes that they spit out ash, and ash is extremely fine dust, and it's so fine, and the reason it's so fine is if you are doing electrical etching, and this is not just my opinion, but if you want to get something really fine, you electrically tear it apart. Like if you say, well, this sand is not fine enough, let's turn this sand to pure dust, you would have to actually electrify it and rip it to pieces to make it want to explode itself. And that's what the ash is. It's so fine, and it makes you question, because obviously, where is that happening? You would think that it would be melted rocks. I mean, we do see certain things that are thrown clear, and they're boulders and so forth, but a lot of that stuff is just as you said, ash, completely fine, and the area that the actual effect of the volcano is just like with a thunderstorm. They say a thunderstorm is this big, but the magnetic or the electric field of that thunderstorm is like 10 times the size of that storm itself. Like you can sense it that much further away than you can actually see the storm. So
we've seen this a lot, and it's like, doesn't it imply like a really strong interconnection between like that volcanic event and its relationship to the atmosphere at that location?
I think it definitely is. I think it is. It's an example of the Earth-sky connection in this capacitive layer. This is capacitance. This is a discharge, a subsurface discharge. It's just like the guy with the jar. The arcing is happening down in the ground, and I think that's what is the result here. Are currents deep within the crust or beneath the crust that are melting and then erupting upwards. But it's electrical because it's connecting to the sky because because of where these loops emerge. If you look at the whole ring of fire, I mean, it's a ring, and beneath it is a thin, the thin continental plates. But I think
in the middle is Hawaii, so you have it going up and down.
But I think that's that's all evidence of the subsurface currents that are then discharging through these volcanoes.
Mm-hmm.
And there's clearly the connection of trying to we don't really know. We say magma chamber. I mean, we know, electrically speaking, that the Earth itself is generally an insulative layer, and underneath that it would be a water layer, which is water-soluble stuff. That's fairly conductive. But so you have dry on top, insulative, but then somewhere in between or somewhere around there is this quote-unquote magma chamber. Now, we do have a general idea that these are real, but we've never stuck a probe in one. The closest we've gotten is to cave systems, which, underneath the ground, like miles and miles down, where they find those giant crystal caves that are right beside the magma chamber of a volcano. Those type of things. And of course, they're filled with crystals, but let's not dwell. Let's not talk about the electrical interpretations here, but that's as close as we get. We don't really know what this is, and there's been lots of talk. Is it like a plasmoid that is a torus going around churning? Is it ripping things apart in there? Is it throwing up material? Is there an electric field that sort of rings it? How are these functioning? One of the things I really liked, Andy, what I saw with you was you showed how over time a volcano got a rim crater right on the rim of one of them, slowly over time. It was like a almost denoting its electrical origin.
Yeah, this was in the Pinacate volcanic field in Sonora, Mexico. I saw a picture of the crater that one of them I was talking about earlier. It's called Cerro Colorado. And it definitely has this. It has this very tight aureole of lava field around it.
Cerro Colorado. What was it called?
Cerro Colorado. And that's
SER.
No, CERRO. Colorado. Mexico.
Mexico. Peru.
We're in
We'll
Peru.
get there from you.
Well, totally screwed up.
Yeah.
This could be interesting,
Let's
though.
try it again.
Look, here's Peru.
Cerro, Colorado. That one?
Well, if you go up to go up to the tip of Baja, the tip of the Gulf of California, Sea of Cortez.
All right, it's basketball there. Okay.
Darn your roundness, Earth.
You see that dark spot that's just to the right of the tip of the Gulf? That dark spot in the sand.
I see it.
Let's see here.
Here.
Along the border.
Up here?
No, down.
No, okay. Your pointer, go just to the right. There's a dark spot right to the right of your pointer. Right there. Okay. Go there. Right there. Zoom in. Okay, now Cerro Colorado is in this. Okay, it's to the right of your pointer, right there where you see Cerro Colorado.
There we go. Okay.
Yeah, we are. Now you stay there for a moment. Mm-hmm. Now you can see how the aureole around that, and that's like, sand, black sand, all around it. It's drawn in. And what I'm suggesting is this was a very powerful eruption that was like a nuclear explosion, and it actually drew the winds into it, the ground level winds into it, rather than blasting them out. The cloud above drew the ground winds in. And if you go down to the rim of the crater, it's even more evident because the winds were drawn in from one direction.
Wow.
From prevailing winds, and they form this rim that you're seeing right here.
Whoa.
It's all lopsided, and it's a drawn in feature, I believe that, And then if you look real close at all these erosion lines that come out of it, they're just amazing patterns. If you just go straight down and look at, I don't know how well the resolution will be, but scan across some of those, and you'll see to the right, especially just look at how the zigzag forms.
Wow.
It's really wild.
Yeah, wow.
So if you go there and you walk around and look at these things, they're even more amazing.
Get it. That's about as clear as we can get. Yeah, wow, amazing though. But you can kind of see like the spatial frequency is about the same, as you go down in there. But the zigzag is certainly zigzaggy,
Well, this area is one of the
very cool.
This area is incredibly dry, and there's just it just doesn't make any sense. If you look at it, you can see that these rills coming out form at the very top of the rim all the way down, and there's just no watershed there to collect, and there's hardly any rain in this area. Anyway, it just doesn't make sense that there are all the way this forms if you look at it.
Uh-huh.
So anyway, up close on examination, you can also see that this thing is layered, and the layers show it was pulled inward, not piled outward. Like an anthill would be pushed out. This is pulled in.
Mm-hmm.
Wow, and you can see like parts of it look like it was hardened, like the stone was somehow fused a little bit better or something, and it lasted longer.
And this also has a rim crater at the top.
I see that.
You see the great big rim crater. I went down and walked through it. I took magnetometer readings too.
Wow. Okay.
Hey, I've got to let my dog in. Just a moment. I'll be right back.
No problem.
I did, by the way. I haven't collated all my data, but I did get a reading across some of these features, measuring with the magnetometer, and you would find certain areas along the rim where there were real high readings.
Oh, okay. So that still even today you're getting there's like some sort of residual current, or do you think it's like magnetic in the ground still?
I think it's remnant magnetism in the ground, in the rock.
That would not surprise me.
A Gauss meter, or just
A magnetometer.
Well, and given the fact that it was aligned when it, if there was sort of like because you can almost see like a swirl to it. Especially right in those areas. Yeah,
you can see how it's layered. See how it's layered, and if you can see that the layering, and then if you're close to it, if you're on it, you actually see how the layer slopes outward, as if it was drawn in rather than blasted out.
Yeah, it looks like it piled on top of piled as it goes inwards.
Yeah, because the dip of the layers is pointing up around the rim.
I like how if I go to some of those parts down near those tendrils that are reaching out from the south part there, with the zigzags in them, that if you look at that and just some of the edges, it's hard to tell the difference between that and whether or not you're looking at a picture from one of Billy Elverton's stills, or something that fly fish might do there, like just.
Oh, absolutely! It looks very much like one of those pits that some of the experimenters produce in the lab. And so this whole area, for future reference, for future geology trips, this is a great area to go for anybody who's interested in crossing the border down into Mexico. And there's a little town nearby called Puerto Penasco, which is a lot of fun, and go down there and get good food and everything real cheap. But this whole volcanic field, you can go in and you can go to some of these.
Stop.
Anyway.
Go back in.
No, yeah, I saw some.
Go to the 7 o'clock position from that. Go to the 7 o'clock position.
I could hardly hear you.
The 7 o'clock position, he said.
This one. Right?
Yeah. Yeah.
So that's called El Elegante. It's another Mar crater.
Whoa, that's deep.
You can see it has a rim crater on its edge too.
Yeah, it does.
This thing is a mile in diameter. This is every bit as big as the crater in northern Arizona. This is a mile wide in diameter, and it's, I think, 700 or 800 feet deep.
And we can go there without having to pay $20, and we don't have to go through an entire bunch of gift shops until we get here. That's good.
Yeah, you can see the road coming in there at about 1 o'clock.
All over the place.
Sorry, go ahead, Andy. There's a road.
You can see the road coming in at about the 1 o'clock position, so you can drive right up there and park and hike up onto the rim of the crater. Now, when I was there, the wind was blowing over this thing like, I don't know, it was like supernatural. The wind was gusting up out of the crater. It was eerie, but it was so forceful. It was hitting gusts of like 50 miles an hour.
I was going to say, me and Robert went to Upheaval Dome, and we went to San Rafael Swell. In both instances, the winds were absolutely stunning. Like, there was a part we climbed to the top of one of those swells there, and I mean, we were leaning. Like, I was so sure that if I wasn't actively working against this wind and leaning into it, that I would just roll away off this edge of this thing and just be, Robert would be hosting the show, and I'd be dead. So we almost fell into a man trap while we were there anyway. So
these things create their own winds, their own weather around them. I've experienced that around these big craters a lot. I was the same way because I was standing up on the rim of this thing, and the gusting winds are just blowing so hard that I'm leaning into them. But I'm trying to look over the edge, and the edges are straight down. And it's like if the wind stops, you just keep going forward.
I think it could create a natural, wind whirlpool. Just because because of that large face on the inside there. It seems like it would spin around.
Yeah, I guess it does. It has a strange effect because you get away from the crater and the winds might be, 5 or 10 miles an hour. It's windy, but not.
Right.
Then you get right up there on the rim and it's something else. It's like amplifies it.
To the west there's a little Upheaval Dome, but it's brown.
Hey, Neil, you remember that rock formation that we were looking at while we were on top of that mountain you were just speaking of? How it like almost vortexed upwards and it was huge. You remember that one?
Okay, yeah.
Because you can almost see how it was coming up. We were looking at it from the 6 o'clock position. It would like start spiraling up at like 5, and then you can almost see the layers wrapping up all the way to the top in a clockwise pattern. If you were to look at it from the downwards, remember that one? Well,
I remember a lot. So, yeah. But I remember seeing some areas that were clearly windswept to a surprising degree, like to a supernatural degree, even. Like they were, like Andy said, not quite going supersonic. I saw Tent Rocks was like that too. It was like, it felt like there was just like a snaking wind, just like West Forks going through it, that was just on the verge of going supersonic, and but the power it had to carve through channels and cracks and stuff. It's almost hard to imagine. And this whole area, yeah, I think you're right, Andy. This might be the next stop that we'll have to make. We'll get a bunch of people and go down there. But we'll. I don't know how to deal with Mexico. We're going to need.
It's fairly simple. This was actually only. It's less than 2 hours across the border. It's about an hour's drive after you cross the border. It's not very far. Just take a passport and you're good to go.
Oh, wasn't worried about that. I just meant I've never been to Mexico and I hear all these crazy things and I'll just need a guide. You'll be my guide.
Actually, it's interesting because you can see the borderline, and you can see that this volcanic field actually touches the border.
Yes, I see that. Yeah.
And the cartels actually hide out in some of these areas just along the border in the volcanic field. So they've closed off the northern entrance to the volcanic field. You can only approach from the south, and you can only go to a certain point because beyond that, they say it's too dangerous.
Wow.
So look forward to that.
It reminds me of like old West cowboy stuff. Like, yes, they're up in the canyons there, but it's just a modern version almost.
Well, where you see Organ Pipe Cactus National Monument, just to the right of that is a valley called the Altar, and it's known as Cocaine Alley. This region of the border right here is very highly unpopulated. It's mostly Indian reservation, and the cartels use it to move a lot of drugs. But before we leave the Pinacati, I wanted to point one other thing out, because I was mentioning that the rills on the side of Cerro Colorado don't really make sense given the amount of rainfall. If you zoom back down and just contrast the rim around El Elegante to the rim around Cerro Colorado, you then can see what I mean. Both of these craters have been there a long time. El Elegante does not show hardly any rills like that around the rim.
He's trying to find it again.
I'm trying to find it again.
Look at the very dark black area, and Cerro Colorado is on the.
Oh, there we go. Yeah.
There you go.
Yeah, thank you.
Okay.
Appreciate it.
Okay, zoom in on. Okay, there you go.
So there's the fingers of the rim. Okay.
Now, on the light-colored, the raised rim on the bottom of the picture, and you can see all those zigzaggy rills shooting through it, okay? And just imagine the rainfall it would take to create that. And these rills start right at the very top of the rim, where there's no place for water to collect, to form a stream.
It would have to be overflowing with a lake to
to the top. You see what I'm saying?
Yeah, yeah.
Okay, so now go to El Elegante, which is just to the southwest.
Right, okay.
Okay, it's coming to view.
There we go.
Now this has a raised rim, and you don't see that. So where's its erosion around the top? You don't see any erosive features until you get away from the rim down into the valley, where there would be a chance for water to collect from a watershed and have sheet flow, and then that would form into rivulets and then eventually streams that would create erosive patterns. There's nothing like that. The two rims are completely different.
Also, at 7 o'clock position on that rim there, Dave, notice the mountain? Right there, yeah. Well, here's a good question. Why are there, where did the water collect to pour off of the edges of around that mountain? Like, look at it. I mean, there's no lake there. I mean, but those are like, I mean, to see them from space, I'm just saying they must be pretty big. But the amount of water, and then they just disappear. Like they're on the ground for like what, a few 100 feet, and they disappear. What's going on there? That's all I mean. Like stuff like that. You can't.
Yeah, exactly. They run for a while and then they just disappear into nothing.
Because that's what water does. Yeah.
There's some really beautiful Lichtenberg type patternings in the lava forms around these, especially around some of the cinder cones.
And look at them; they just look like they pow, 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 pow. I mean, look at there's a field right to the left there. Am I going blind, or is that just like a ton of little tiny craters
up in here?
Yeah, look at them all, like all from the top all the way to the lower left. I mean, look at them go. See, just cinder cones everywhere.
And look at the chains of them. There's one. They form in chains. A lot of them.
Well, just like electricity. Yeah, exactly like they should. Wow.
Yeah.
Since we're close here, there's another really cool feature I'll just point out.
Welcome to Andy's Playtime Hour. Let's go.
That is awesome. Yeah. That's really
But
awesome.
the deep black patch of lava down at the bottom, center that. Now, just to the bottom right of that, you see the white sands and with the black.
Oh yeah, with the black tendrils there.
Now, this is a playa that is dead flat, and yet it has these weird black patterns across it.
Oh, zoom in, yeah.
So this was in the area of the no-go area north of Cerro Colorado, where they say you can't go because of the cartel activity. So I didn't get to go out and walk out there and see if this is black rock or vegetation or what. But it appears from Google Earth on my resolution, it appears to be rock.
Yeah, just like lava rocks. I saw some of these when we were going over when I was driving, across New Mexico or something, and I was looking up to the side and I saw just lava rocks interdispersed, but in conglomerates, like in conglomerations, and then they would be gone again. Like, does lava do this? Like, what's going on here?
I think it goes under the surface.
Well, yeah, they get buried or something. It looks like almost, but. And Andy showed me another thing. Like you down by your place in Tucson, there was this place that you showed. Like it looked like a field, and if you were you would guess that it was like bushes or plants or something. But when you zoomed in, you went out to them, and you found it was like big round circles with a pile of like an anthill in the middle type thing.
Right. Well, yeah, they appear to me to be. For sure, lightning strikes, and where the lightning bolt drew up the sand around it and formed a crater with an anthill shaped form in the center. But these piles of sand in the center are dusted over with cinders, like cinder rock, as if it fell out of the ark when the ark finally extinguished. Whatever was left up in the channel rained back to earth right on top of the pile and sprinkled it with these little cinders. And there's no ants in them. These holes are dotting the landscape, and they're in this random pattern, but they cover huge swaths of land. That was up near Monument Valley where I looked at a bunch of those, but they're all over we could find some around here probably if we looked long enough.